This is SpaceTime Series 29, Episode 32, for broadcast on the 16th of March 2026. Coming up on SpaceTime, the birth of a Magnetar seen for the first time, rewriting the textbooks on the history of the Earth's moon, and a spectacular fireball lights up the night skies across Europe. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have for the first time seen the birth of a Magnetar, a highly magnetized spinning neutron star. The discovery, reported in the journal Nature, confirms that they are the power source behind some of the brightest exploding stars in the universe. The findings have established a new phenomenon in exploding stars, that is, supernovae with a chirp in their light curves, caused by general relativity. Superluminous supernovae, which can be up to 10 times brighter than your average exploding star, have puzzled astronomers ever since their discovery in the early 2000s. They were originally thought to simply be the explosion of stars more than 25 times as massive as our Sun. The problem is, they also remain bright for much longer than what would be expected when a star's iron core collapses and its outer layers are subsequently blown off. Now, in 2010, astrophysicists proposed that a magnetar was powering the long-lasting glow. According to the hypothesis, when a massive star collapses at the end of its life, it crushes much of its mass down into a super-dense compact object called a neutron star. Neutron stars are the densest objects in the universe, other than black holes. Just a teaspoonful of neutron star material would literally weigh billions of tons. Now, if the star originally had a very strong magnetic field, it would have been amplified during magnetar formation, producing a field 100 to 1,000 times stronger than that of a normal spinning neutron star, what we call a pulsar. Pulsars and their highly magnetized big brothers magnetars are only about 12 kilometers or so in diameter, but in their youth they can spin up to 1,000 times per second. These are millisecond pulsars. As the magnetar spins, the spinning magnetic field can accelerate charged particles, which then slam into the debris from the expanding supernova, increasing its brightness. Magnetars are also thought to be the source of some fast radio bursts. Joseph Farah from the University of California, Santa Barbara, confirmed the connection between magnetars and Type 1 superluminous supernovae after analysing data from a supernova located a billion light-years away and catalogued as SN 2024 AFAV. Farah and colleagues proposed a general relativistic explanation for the unusual bumps in the light curve of this supernova, which they call chirps. The explanation conclusively connects it to a magnetar. That original 2010 model proposed that a significant fraction of the energy of the magnetar will get absorbed, generating the superluminosity. Farah's work, finding the chirp in SN 2024 AFAV, demonstrates that a magnetar did in fact form in the middle of the supernova. After SN 2024 AFAV's discovery in December 2024, the Los Cumbres Observatory, a network of 27 telescopes stationed around the world, tracked it and measured its brightness for more than 200 days. Farah and colleagues noticed that after the brightness peaked around 50 days after the explosion, it didn't gradually fade like typical supernovae do. Instead, its brightness slowly oscillated downwards, with the period of the oscillations gradually shortening, producing a series of 4 bumps. Previous superluminous supernovae were known to have a couple of these bumps in their decaying light curves, which some astronomers have interpreted as the supernova shock colliding with layers of gas clumped around the star, briefly causing it to brighten. But until now, no one had observed 4 of these bumps. Now, according to Farah's model, some material from SN 2024 AFAV's explosion fell back towards the magnetar, forming an accretion disk. Since material around the magnetar is unlikely to be symmetric, the accretion disk would not necessarily be symmetric around the spinning neutron star either, and that would lead to a misalignment of the magnetar's spin axis and the spin axis of the accretion disk. And this is where Einstein's general relativity comes in. It states that a spinning mass drags space-time with it. It's called frame dragging, and the spinning magnetar would produce an effect known as lens-thirring precession. That is, it would make the misaligned disk wobble. A wobbling disk could periodically block and reflect the light from the magnetar, turning the whole system into a strobing cosmic lighthouse. The time for this to repeat decreases with the radius of the disk. So, as the disk slides inwards towards the magnetar, it wobbles faster, causing the light to oscillate more rapidly as it fades, creating the chirp observed in telescopes. The authors tested several ideas, including pure Newtonian effects and precession driven by the magnetar's magnetic fields. But it was only lens-thirring precession which matched the timing perfectly. Farris says it's the first time general relativity has been needed to describe the mechanics of a supernova. The astronomers also used observational data to estimate the neutron star's spin rate, finding it to be 4.2 milliseconds, and the magnetic field, around 300 trillion times that of the Earth, both hallmarks of a magnetar. Now, this discovery doesn't mean that all superluminous supernovae are powered by magnetars. An alternative hypothesis involves the shockwave from the exploding star hitting material surrounding it, bumping up its brightness. Now, if the collapse of the star results in a black hole, that could also power a brighter supernova. And if it also has a misaligned accretion disk, produce bumps in the light curve. Magnetars are an exciting field of astronomy and stellar astrophysics, with many more mysteries yet to be solved. This report from NASA TV.
A high-energy outburst seen in April 2020 confirmed the surprising range of supermagnetized objects called magnetars. This blast of X-rays and gamma rays triggered instruments on several spacecraft. The eruption was over in the blink of an eye and originated from a galaxy about 11 million light-years away. Magnetars are part of the family of compact objects known as neutron stars, the crushed leftover cores of exploded stars. What makes magnetars special are their incredibly strong magnetic fields, up to 1,000 times stronger than a typical neutron star's. Sudden changes to this ultra-strong field are thought to drive brief, enormously powerful outbursts called giant flares. One giant flare in our own galaxy affected Earth's upper atmosphere from 28,000 light-years away. Detectors on NASA's Fermi, Swift, Mars Odyssey, and WIND missions, as well as on the European Space Agency's Integral satellite, picked up a rapid surge of X-rays and gamma rays. Using the arrival times of the signal at different spacecraft, astronomers pinned the burst to NGC 253, a bright, nearby galaxy. From start to finish, the event lasted just 140 milliseconds, as fast as a finger snap. Astronomers see gamma ray bursts, or GRBs, almost every day. We know that at least some of the shortest GRBs come from merging neutron stars, more than 100 million light-years away. But a GRB located in our own galactic neighborhood should have appeared much brighter. As astronomers explored this new burst in detail, they found it looked less like a short GRB and more like a magnetar giant flare. Astronomers have recorded 2 such flares inside our own galaxy and a third in a satellite galaxy. All of these bursts displayed a spiky tail as they faded out. The spikes form as the flare's hotspot spins in and out of view like a lighthouse beam. Current instruments can't detect this feature in flares located at great distances, but other characteristics, such as their extremely fast rise in brightness, are unmatched by short GRBs. This fueled astronomers' growing suspicions that short GRBs associated with galaxies in our neighborhood might really be magnetar giant flares. Now, the precise localization of the 2020 event to the disk of the Sculptor galaxy has unmasked them at last. Astronomers suspect that a few percent of observed short GRBs may in fact be giant flares, high-powered eruptions in our galactic backyard, produced by the strongest magnets in the cosmos.
This is SpaceTime. Still to come, rewriting the textbooks on the history of the moon, and a spectacular fireball lights up the night skies across northern Europe. All that and more still to come on SpaceTime. A new study claims the lunar near and far sides experienced similar levels of asteroid and meteor bombardment despite their very different appearances. And the new findings contradict earlier suggestions that the far side of the Moon experienced intensified levels of bombardment compared to the hemisphere facing the Earth. The dichotomy of the two sides of the Moon have long intrigued astronomers, with the near side dominated by vast basaltic volcanic plains called mare, while the far side has a much thicker crust, with a rugged, heavily cratered and mountainous terrain. The new study supports the unified global lunar cratering chronology technique, which links crater density to absolute radiometric ages. Scientists use crater density to provide a rough determination of the average age of a celestial body's surface. In simple terms, the more craters, the older the surface is likely to be. These new findings, reported in the journal Science Advances and the Proceedings of the National Academy of Sciences, are based on lunar regolith collected by China's Chang'e 6 sample return mission, which was the first to visit the far side of the Moon. Those samples were then compared with similar samples from missions to the lunar near side. The new findings address how impact structures have recorded the cumulative effects of asteroid and meteor bombardment since the Moon first formed some 4.5 billion years ago. It allows scientists to estimate ages for larger areas of the Moon that lacked return samples, and also provides the foundation for aging estimates for other bodies across the inner solar system. But some previous studies have suggested that differences in crustal structure or shielding by the Moon's host planet, the Earth, might mean that impact fluxes differed between the near and far sides, raising questions about the universality of the existing model. Previously, all samples used to calibrate this chronology came from the lunar near side, leaving open the possibility that it may not accurately describe the global impact history of the Moon. Another problem involved the possibility that many of the Apollo mission's impact-related samples, which were all collected from the lunar near side, showed ages clustering around 3.9 billion years. And that led to the late heavy bombardment hypothesis, which suggests a period of extra intense impact events, possibly caused by the outward migration of the gas giants Jupiter and Saturn as they moved to their current orbital positions. But it's also possible that the same clustering at 3.9 billion years could simply be a sampling bias rather than a true system-wide bombardment spike. The idea being that much of these impact samples could simply be caused by a single massive event, say ejected debris from the formation of the Imbrium Basin. Chang'e 6 touched down in the Apollo Basin region of the South Pole Aitken Basin, the largest and oldest recognized impact basin on the Moon. Analysis shows that its samples are dominated by local basaltic material, with a radiometric age of about 2.807 billion years. That provides a crucial far-side calibration point for comparing impact fluxes between hemispheres. Chang'e 6's collection also includes noritic rock fragments dated to 4.247 billion years. These crystallized impact melts produced during the formation of the South Pole Aitken Basin provide a direct constraint on the timing of this impact event. But these noritic samples are also inconsistent with the classical late heavy bombardment model, instead favouring the idea of a gradual decline in impact activity following the main phase of planetary accretion in the inner solar system. This is space-time. Still to come, a spectacular fireball streaks across the skies of northern Europe, and later in the science report, the weird crocodile that walked on two legs. All that and more still to come on SpaceTime. The European Space Agency is analysing a spectacular fireball which lit up the night skies over Europe last week, dropping debris all along its trajectory. The meteor streaked across the early evening skies out of the southwest, travelling in a northeasterly direction. It was observed by thousands across Belgium, France, Germany, Luxembourg and the Netherlands. Witnesses say it glowed for around 6 seconds, leaving a visible trail in the sky as it fractured into pieces. The event was recorded by dozens of dedicated meteor cameras, including the European All-Sky 7 Fireball network, as well as hundreds of cell phones, security cameras and dash cams. Some observers also reported the event was audible from the ground. At least one house in Germany was reported to have been struck by small pieces of the resulting meteorites. There have been no reports of any physical injury. The European Space Agency's Planetary Defence Team says it's now working to determine the object's original size, which is thought to have been up to several metres in diameter. The agency claims that objects in this size range strike the Earth between once every few weeks and once every few years. The timing and direction of the impact indicates the object was likely not visible on any large-scale telescope sky surveys which scan the night skies for such objects. Now, that's not unusual. Remember, so far only 11 space rocks destined to hit the Earth have actually been detected prior to their atmospheric entry. Small objects approaching the Earth from brighter daytime regions of the sky, even around dusk as in this case, are often missed because of the glare of the sun. This is Space Time. Time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns there's little scientific evidence to show that cannabis really can help people who are suffering from mental health conditions. The findings, reported in the Journal of the American Medical Association, looked at the available evidence to assess the use of cannabis for a variety of mental health conditions, including post-traumatic stress disorder, anxiety, depression, bipolar disorder, ADHD, and psychosis. The research showed that along with the lack of evidence of the effectiveness of cannabis to treat these conditions, using dope also comes with its own risks, including worsening mania symptoms, a lack of ability to cope with life among bipolar patients, and an increase in psychotic symptoms. The authors also report that around a third of people who use cannabis develop a cannabis use disorder which starts to interfere with their everyday lives. And that means more than just ordering pizzas at 3 a.m. The authors say there's currently simply not enough evidence to support the use of cannabis for the treatment of mental health conditions, and use should be discouraged among young people and those with conditions such as bipolar or psychosis. Well, the latest move by Australia's Socialist Labor government to force its citizens to adopt a digital ID scheme has now come to fruition, with people being forced to verify their ages through digital documentation in order to access R-rated video games and websites. It follows last December's legislative changes preventing kids under 16 from accessing social media platforms except for left-wing sites like Blue Sky. Australians have repeatedly rejected the idea of federally mandated ID schemes like the so-called Australia Card. The fear is digital ID will eventually place all your data, including employment and medical records, your driver's license, your finances, your internet history and online activities into a single file, which could then be easily accessed by politicians and bureaucrats. It means digital IDs could be used as a clandestine way for governments to introduce a version of China's infamous social credit scheme, in which authorities can monitor what you say and access online and punish you for inappropriate thoughts and actions, restricting where you can live, your ability to travel, your access to medical treatment, and even which schools your children can go to. And if you think that's far-fetched, remember Australians already had their first taste of this Big Brother approach when police in Victoria and Western Australia began using COVID-19 digital passes to track people's movements. A weird ancient relative of crocodiles, which lived during the age of the dinosaurs, some 225 to 200 million years ago, may have started life on 4 legs before learning how to walk on just 2 as an adult. A report in the Journal of Vertebrate Paleontology found the fossils had unusual proportions, which led them to believe that this poodle-sized reptile, Soncellosuchus cedrus, had learnt how to walk on 2 feet. They think that Soncellosuchus had more proportional forelimbs and hind limbs when they were young, but the hind limbs grew longer and more robust as they moved to adulthood. Well, it looks like a psychic from Pakistan who predicted the end of the world appears to have gotten it wrong. The Skeptics' Tim Mendham says the doomsayer's teachings combine Sufism with eschatology.
People are so keen to predict doomsday. I don't know what benefit it gives them because they're obviously not going to get any money once it happens. What he created is a fellow named, a spiritual leader named Riaz Ahmed Shahi, who predicted back in a book he wrote in 2000, or that came out in 2000, that the Earth would be destroyed, colliding with a comet, resulting in the annihilation of all life forms before the end of last year, 2025. He said this thing would happen in the next 20 to 25 years in his book that came out in 2000. So it should have happened by now. It hasn't happened by now, obviously. He claims this is going to happen because of its retribution for humanity straying too far from spiritual truths. He's got a fairly wide-ranging sort of predictions, about discovering breakthrough medicines which can prolong the aging process. You'd hope to reverse it, but anyway, or a medicine that can defeat death. It happens occasionally. Most predictors don't like doing complete disasters, but all life will be wiped out. I can't see the point. I don't know what you can do about it to avoid it, for a start, and I don't know what benefit he's going to get out of it apart from saying, oh, he's a predictor who predicted this thing 20 years in the future. He must be real. We've done predictions. Australian skeptics have analysed predictions, thousands of them, several hundred Australian psychics and predictors, and they found out they were appalling in their accuracy. 11% of these thousands of predictions were accurate, but they're also fairly general, that they could apply to a lot of different things, or they were the bleeding obvious, even though that was a category as well. But in most cases, they were wrong. They were actually wrong. And you think that this sort of spiritual leader, if they're making predictions that are generally, largely, almost entirely wrong, you'd think there's something wrong with that industry. And funny enough, there is.
That's the Skeptics' Tim Mendham, and this is Space Time. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.